7 minutes to understand dielectric performance of vacuum interrupter. Vacuum interrupter are widely used in medium circuit breaker. Why? And first of all, what is vacuum? Vacuum is space devoid of matter. In fact, real vacuum doesn't exist. So we should speak about partial vacuum. The quality for vacuum is inversely proportional to the number of particles present in a volume. For example, in a cubic centimeter of air, at 1 bar, we have 10 power 19 particles. At 1 millibar, we have 10 power 16 particles. Another value which defines the vacuum quality is the mean free path. It is the average distance a particle will travel before a collision with another one. It increases when the number of particles decrease or when the pressure decrease. What level of vacuum we have in the cosmos? On Earth's surface we have 10 power 19 particles per cc. 65 km above sea level. Where start thermosphere we have 10 power 14 particles per cc. Atmosphere on the Moon contain 10 power 11 particles per cc. And interplanetary space there are only 10 particles per cc. And in interstellar space only 1. What vacuum? For a vacuum interrupter. A vacuum interrupter uses the vacuum as an isolation medium. To be insulating, the vacuum should good enough to prevent gas breakdown. This happened through Townsend avalanche or electron avalanche phenomena, which we going to explain. Take a simplified model of vacuum bottle with a cathode and an anode separated by 1 centimeter. In this case we have a good vacuum, means of pressure under 1 Pascal, and mean free path of 1 centimeter. If one of the particle is excited, it become ionized and liberate an electron. The electron accelerate toward the anode. The liberate electron will reach the anode without finding other particle on his way. There is no gas breakdown. Now let's take the same model of vacuum interrupter but this time with a bad vacuum. A bad vacuum means a pressure between 1 Pascal and 100 pascals. If a particle is excited it will liberate an electron which will accelerate toward the anode. The electron will collide with other particles with enough kinetic energy to liberate another one. A chain reaction leads to avalanche breakdown and a dielectric arc. There is a gas breakdown. In the last case we have a pressure higher than 100 Pascal. An excited particle will still liberate an electron. The mean free path is so small that the electron cannot accelerate enough before a collision. It will not be able to extract other electron which is needed to create an avalanche breakdown. The electron will even lost energy with its collision during its travel toward the anode. There is no gas breakdown. These phenomena could be reproduced on a curve called Paschen curve. This is the Paschen curve for nitrogen, which the main component of air, drawn for a gap of 1 centimeter. Here we move from the left to the right at a defined voltage we got withstand. Breakdown. Withstand. But on the far left of the curve we see that there is a limit of dielectric withstand. The dielectric withstand is limited by other phenomena linked to contact surface and not to gas. The dielectric withstand is not any more relative to the vacuum level under 10-2 millibars. Two main others processes limit this withstand: field emission and detachable particles. Field emission is the release of electrons by the contact surface under high dielectric field.
But vacuum interrupter should be designed to be under this threshold.
Yes. But on contact at microscopic level there are some spot. Around the spot the dielectric field could be 100 times higher. and liberate a lot of electrons, which will cause breakdown. High local current will tend to melt these spots, which will restore the dielectric performance. A particle set free, either by a shock or by electrostatic forces, is attracted by an electrode. This shock can create local rise of gas density by desorption of the electrode. This can lead to a gas breakdown. The particle melt on the electrode surface can also trigger a field emission process. These processes are complex and not easy to predict, but they are self-healing. This will conclude this short video on physics phenomena and vacuum interrupter. Remember, vacuum reach its maximum dielectric withstand under 10⁻² millibar. Above this value, Townsend avalanche phenomena limit the dielectric performance. Under this value, field emission and detachable particle cause dielectric breakdown. At 1 millibar, the dielectric withstand between a 1 cm gap is only around 300 volts. The dielectric withstand is not pressure relative under 10⁻² millibars.